Something entered our solar system and didn't slow down. It didn't announce itself. And right now, at this exact moment, it is silently threading past Jupiter, a billion-year-old object from the space between stars. We cannot explain what it is. We cannot explain where it truly came from. And we cannot explain why, of all the directions in the universe, it came here. On July 1st, 2025, the Atlas Survey Telescope in Chile, a system designed to hunt asteroids that could end civilization, caught a faint smear of light moving against the fixed stars. The astronomers ran the orbital calculations. Then they ran them again. The object's velocity, approximately 67 kilometers per second relative to the Sun, produced a result that made the room go quiet. A bound object, a comet, an asteroid, anything born in our solar system, follows an elliptical path. It curves back. This did not curve back. Its orbit was hyperbolic. Decisively, unambiguously hyperbolic. This object did not come from our solar system. It came from somewhere else entirely, and it is not staying. They named it 3I Atlas, the third confirmed interstellar visitor in all of recorded human history. The first was Oumuamua in 2017, cigar-shaped, reddish, and, this is the detail that still has no consensus explanation, it was accelerating as it left, not decelerating as solar radiation pressure would predict for a normal object. Accelerating, without any visible jets, without any detectable outgassing. It was gone before we could properly study it, leaving behind a mystery so unsettling that a Harvard astrophysicist formally proposed it might be artificial. The second was 2I Borisov in 2019, a comet from another star system, familiar enough in behavior that we almost forgot to be disturbed by it. Almost. And now the third. But 3I Atlas is not like either of them. Preliminary measurements suggest a nucleus potentially several kilometers across, larger than both predecessors. And it is active. Spectacularly active. A visible coma, a cloud of gas and dust surrounding the nucleus, confirms it is outgassing, vaporizing, responding to the sun's warmth for the first time in what may be a billion years. Whatever chemistry is locked inside that object has been frozen solid in the dark between stars since before complex life existed on Earth. And then there is its direction of origin. 3I Atlas came from the approximate direction of Draco, the Dragon constellation, but not from the galactic plane where most wandering debris naturally drifts. It came from above it, high above the disk of the Milky Way. This means it likely originated in a star system that is, or was, positioned well outside the galactic midplane, a stellar environment different from our own neighborhood in ways we cannot yet characterize. We have a window to study 3I Atlas measured not in years, but in weeks. After that, it will be gone, back into the dark, forever. And the clock is already running. But the most disturbing part is not what 3I Atlas is, it's what it did on the way here. It passed Jupiter. And what happens near Jupiter, in this case, changes everything about how we should think about this object. Let's establish what normal looks like, so you understand precisely how abnormal this is. Every star system in the galaxy ejects material. Comets get perturbed by giant planet gravity and flung outward. Asteroids collide and scatter. Over billions of years, the galaxy has filled with a slow blizzard of interstellar debris, rocks, ice, and dust drifting between stars at the speeds of their parent systems. Current models predict we should detect roughly one such interstellar object per several years with modern telescopes. Oumuamua, 2017. 2I Borisov, 2019. 3I Atlas, 2025. 3 in 8 years. Either our detection technology improved dramatically, which it did, or the interstellar environment near our solar system contains more of these objects than models predicted. Perhaps both. Perhaps neither. Here is where the science sharpens into something unsettling. 3I Atlas shows active outgassing. In a standard solar system comet, this is expected. Heat from the sun sublimates ice directly to gas, and the gas drags dust outward into a visible tail. But 3I Atlas was already producing a notably bright coma earlier in its approach than models predicted for a simple icy body at that distance. This could mean an unusually volatile composition, different ices from a different stellar chemistry, responding faster to solar warming than anything we've cataloged before. It could mean its surface was already partially processed by cosmic ray bombardment during its billion-year transit between stars. Or it could mean something about its material properties that we simply don't have a framework for yet. We don't know. And in this field, "we don't know" is both the most honest and the most terrifying sentence in the language. Now I want you to sit with a number. 2 trillion. That is the estimated number of galaxies in the observable universe. In our galaxy alone, the Milky Way, there are hundreds of billions of stars. The majority of them host planets. Many of those planets orbit in zones where liquid water is possible. By pure probability, by the mathematics of scale alone, life should be everywhere. Intelligent life, technological life, civilizations that have had billions of years longer than us to develop and expand. And yet, silence. Total, absolute silence. No signals, no visitors, no evidence. This is the Fermi paradox, and it has no comfortable answer. There is one proposed solution that astrophysicists and astrobiologists treat with genuine, uncomfortable seriousness. It comes from physicist and author Liu Cixin. He called it the dark forest theory. And once you understand it, you cannot look at the night sky the same way. The theory requires only 2 axioms. First, every civilization that exists wants to survive. Second, the resources of the universe, matter, energy, habitable space, are finite. From these 2 undeniable facts, a cold logic emerges. If you encounter another civilization, you cannot verify their intentions. You cannot know their true capabilities. You cannot know whether in 10,000 years they will grow powerful enough to threaten you or destroy you. Given infinite time and finite resources, the safest move, the only rational move, is to eliminate the unknown before the unknown eliminates you. And every civilization in the universe eventually arrives at the same conclusion from the same logic. Hide. Go silent. Emit nothing. Send nothing. Because to announce your existence is to paint a target on your world. In the dark forest, the universe is not empty. It is full. And everything in it is hiding. This reframes the Fermi paradox entirely. The universe isn't silent because life is rare. It's silent because everything alive in it learned, the hard way or through calculation, that silence is survival. Now look at 3I Atlas again with those axioms in mind. An object from interstellar space. Origin, unknown star system above the galactic plane. Trajectory, threading with precision through our solar system. Active, alive with chemistry, larger than anything like it we've ever seen. Moving too fast to be captured. Moving too purposefully, at least in appearance, to feel entirely random. What if 3I Atlas is not debris? What if it is a listener? Not a spacecraft from a science fiction film, not blinking navigation lights and alien inscriptions. Something far older and far quieter. A passive probe, the size of a mountain, built perhaps 1 billion years ago by something that may no longer exist. Designed to drift between star systems, absorbing data, and continue on. A device that requires no maintenance because it requires no power. No signal back, just observation, just recording, just noting who is home.
In the dark forest, you don't announce yourself. You observe, you mark. And then something, somewhere, receives that record. We don't know that 3i Atlas is this. Science cannot confirm it. But science, with the data currently in hand, cannot rule it out. And here is the detail that should keep you awake tonight. 3i Atlas passed through Jupiter's gravitational influence on its way inward. And Jupiter, the solar system's ancient, silent gatekeeper, may have just handed this object a slightly different course than it arrived with. Jupiter, 11 times the diameter of Earth. Over 1,300 Earths could fit inside its volume. Its magnetic field is the largest structure in the solar system after the Sun itself. For 4.5 billion years, its gravity has patrolled the outer solar system, deflecting, capturing, or ejecting comets and asteroids that might otherwise threaten the inner planets. Some planetary scientists believe that without Jupiter's gravitational shielding, Earth would have been bombarded so relentlessly that complex life might never have stabilized. Jupiter, in a very direct sense, is one of the reasons you exist. And 3i Atlas passed through Jupiter's gravitational sphere of influence as it angled toward the Sun. The precise effect is still being refined by orbital dynamicists, but we know this. Jupiter can alter the trajectory of passing objects measurably. It can shift closest approaches to the Sun. It can change observation windows. It can, in theory, slightly redirect an object's outgoing vector, where it goes next. What it cannot do, what nothing in our solar system can do, is stop 3i Atlas. At 67 kilometers per second, it is simply moving too fast. It is not bound to our Sun. It never was. It came. It passed Jupiter. It will pass the Sun. And then it will leave. Back into the dark between galaxies. Back into the billion-year silence it came from. But consider what that trajectory implies statistically. 3i Atlas is one object, one we detected. How many passed through before we had telescopes, before we had orbital mechanics, before we had any awareness that the sky contained travelers? By statistical models, based on the density of interstellar objects now estimated in the galaxy, hundreds of thousands of such objects may have passed through our solar system over its 4.5 billion-year history. Some may have come within the inner solar system. Some, by probability, may have come closer to Earth than 3i Atlas will. And we never knew. Not once. We were visited repeatedly, and we were completely unaware. In 1977, we launched Voyager 1, a golden record of human music, mathematics, and language, a declaration of existence thrown into space with hope and pride. We carved our location into a plaque and sent it outward. We wanted to be found. We announced ourselves. In the language of the dark forest, we lit a fire in the dark and called out. What if something heard us? What if the answer is not a radio signal, not a light in the sky, but a silent, billion-year-old object threading past our planets, noting our warmth, our signals, our noise, and continuing on. What if 3i Atlas isn't the visitor? What if we are? A brief, loud, fragile species on a pale blue dot, surrounded by a silence that is not emptiness, but patience. The universe is under no obligation to make sense to us. It owes us no warning, no contact, no explanation. It existed for 9 billion years before our sun ignited from a cloud of gas and dust. It will exist for trillions of years after our sun expands and swallows this planet whole. We are a momentary flicker of complexity in an indifferent cosmos. Curious, fragile, and deeply uncertain that anything out there shares our certainty. That we matter.
3i Atlas will not answer that question. No object from the dark ever does. It came, it moved through our neighborhood with the silence of a predator or the silence of physics, and we cannot tell the difference. But somewhere in the vast, cold machinery of the cosmos, that passage was recorded. Whether by the mathematics of orbital mechanics alone, or by something else. That question will outlast every single one of us. It's already leaving. We like to imagine first contact as a moment of grandeur, a signal decoded, a ship in orbit, a message in a language we learn to translate. But the universe may not deal in grandeur. It may deal in silence, in ancient trajectories, in objects that pass through without ceremony and leave behind nothing but a question we cannot stop asking. 3i Atlas does not care whether we found it. It does not care whether we decoded it. The billion years it spent in the dark between stars were indifferent to our entire history, our wars, our art, our science, our hope. And perhaps that is the most important thing it teaches us. Not a lesson about aliens, not a lesson about probes. A lesson about scale. About how small a flame we are in how vast a dark. And how extraordinary it is, how genuinely extraordinary, that we can look up, find a moving light among fixed stars, run the numbers, and ask the right question, even if the universe never answers. If that cold, unfiltered truth is what you came here for, subscribe and keep decoding the dark reality of the universe via Aius.